In this video, we are going to determine whether the sum of certain terms in a geometric sequence is greater than a given value. In the question, an is the nth term of a geometric sequence, and a3 and a4 are given as -6 and -3 respectively. We need to find the second term first, and then determine whether the sum of the second, fourth, sixth, up to the 2nth term must be greater than -20, and explain the answer. Part A. Find the second term of the sequence. It's straightforward. Let R be the common ratio of the sequence. We can find R by dividing the fourth term by the third term, which is equal to 1/2. Then we can find the second term by dividing the third term by the common ratio. So A2 is equal to -12. Part B. We need to determine whether the sum of A2, A4, A6, so on and so forth, until A2n must be greater than -20, and explain the answer. Can we use the summation formula to express the sum of the first 2n terms and find the answer? You must notice that the required sequence only includes the even-numbered terms, so we can't apply the summation formula directly. Instead, we should consider a new sequence, A2, A4, A6, so on and so forth, expressing each term of this sequence in terms of A1 and R. We can observe that this new sequence is also a geometric sequence. For this new sequence, the first term is A2, which is -12, and the common ratio is R squared, that is 1/4. So the sum of A2, A4, A6 until A2n is the sum of the first n terms of this geometric sequence. How could we determine whether this sum is greater than -20 for any n? Think about the sum to infinity. For any geometric sequence where the sum to infinity exists, if all its terms are positive, the sum of the first n terms must be less than the sum to infinity. If all its terms are negative, the sum of the first n terms must be greater than the sum to infinity. The common ratio of this sequence is 1/4, which is between -1 and 1, so the sum to infinity exists. And the first term is negative, while the common ratio is positive, so all the terms of this sequence are negative. As a result, the sum of the first n terms of this geometric sequence is greater than the sum to infinity of this geometric sequence. By the formula of sum to infinity, the first term, -12 over 1 minus the common ratio 1/4, we have the sum to infinity equals -16, which is greater than -20. Therefore, the sum of A2, A4, A6 until A2n is greater than -20 must be true. That's it.